Hey there, everyone, it's Alejandro. Welcome back for day 350 of me doing Daily LeetCode challenge after reach 1 year's worth of green contributions here on GitHub. So today's round is for July 1st, 2025. Without further ado, let's get straight into it. Oh boy, so July 1st, 2025, we are in the last month of my Daily LeetCode challenge because July 15th will be the last day, the 365th day that I do this. And to start off the month, we get a LeetCode easy from 3330. Find the original type string 1. Okay, Alice is trying. I'm guessing that tomorrow's probably going to be version 2. Alice is attempting to type a specific string on her computer. However, she tends to be clumsy, just like me, and may press a key for too long. Oh, resulting in a character being typed multiple times. Okay, this is actually kind of funny because today is a Monday, and I came out from work, and on my computer, I was typing like no with like a bunch of O's. And then my O key was like stuck, and just like no matter what browser I open, no matter what application I open, it like kept going oh. And so I figured it was like a hardware issue, and so I actually removed the O key, looked inside, and was like, what the hell? There's nothing pushing it. Button is normal, and so on. So I put a glue back. Didn't glue back. Just put back the O key. I ended up restarting the computer, and as you can imagine, restarting the computer worked to solve the problem. So maybe we tell Alice she should just, restart her computer, right? That would solve the problem. Okay, that would make it at least easy. All right, although Alice tried to focus on her typing, she is aware that she may still have done this at most once. Okay, you're given a string word which represents the final output displayed on the screen. Return the total number of possible original strings that Alice might have intended to type. A, B, 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 C, 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 C. What? Okay. Oh, all the ones that are double, I see. Okay, this should be easy, right? You add 1 whenever a character is equal to the previous one, right? So like here, it's like you add 1, 2, 3, 4. Ooh, okay. Or is it just going to be that and then plus 1? Yeah, and then it's just going to be plus 1, right? Before the original string itself. Right? Okay. Res is equal to 1. Original string itself. Word itself. And then we're going to say char equals none. Prev letter equals none. For letter in word, if letter res plus or equal to prev letter equals letter, and then prev letter equals letter. Return res, right? Something like this. Yep, it's accepted. Let's submit. And there we go. Bada bing, bada boom. Completion streak 350 days. Consistency is key. See ya tomorrow. Okay, 31 MS beats 92.39% of submissions, which is absolutely fantastic. Okay, so nevertheless, as always in my videos, I do a quick recap of the most solid prompts. For this one, very straightforward. It's a LeetCode easy. Alice is basically attempting to type a string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being multiple times. Blah, 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 blah. You're given a string word, which represents the final output that Alice wrote, within the total number of possible original strings that Alice might have intended to type. So the way that I figured this out is I looked at an example here, right? A, B, B, C, 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 and here are the possible strings, right? The possible strings are, the original string itself, and you'll notice that for all of these, the original string itself is always a solution, right? Maybe she didn't type anything too long. Or maybe we should have removed 1 of the duplicate C's, or maybe 2 of the duplicate C's, or maybe 3 out of the 4 duplicate C's, or maybe we keep all 4 C's, but we remove 1 of the duplicate B's, right? So every time a character is, 1 more than the previous one, that's like, did Alice mean to type that, or is that one of the extra characters Alice actually typed, right? So the way that I solve this problem is I set my result equal to 1 originally, because it could be that the entire string itself is what Alice actually meant to type. Right? For example, A, B, C, D, there's no repeated characters, but the output is still 1 because, there's 1 possible string, the string itself, right? Otherwise, every single time I see a duplicate letter, right, one that is equal to the one that's before it, then I know that could have either been a case where Alice intended to have that character or Alice did not intend to have that character, right? So I'm going to add 1 for that character because it's like maybe Alice didn't mean it, right? So essentially, what I'm going to see is like, okay, for every instance where a certain character is equal to the previous character, that could be a character that could potentially delete or keep, right? I don't know if Alice meant it or not, but I'll add 1 to my result because of it. So all I'm going to do is count the number of instances where the current letter is equal to the previous letter, right? So here I initialize previous letter equal to none because I know none of the letters in here will be equal to none because, yeah, word only consists of lowercase English letters. None in Python is definitely not a lowercase English letter, right? So just some dummy value at the very beginning. But otherwise what I'm going to do is I'm going to go through every single letter in Word. And every single time I see that the previous letter and the current letter are equal to each other, for example, over here, this B is equal to the previous letter, which is also a B, then I'm going to add res by 1, right? This will evaluate to a Boolean. If it's true, it'll be like +1 or res. If it's false, it'll be +0, right? I could do 1 if this, else is 0, or I could do if brev letter equals letter, then res plus or equal to 1, right? It's just me being lazy here with Python evaluation tricks, blah, 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 right? So I add to res 1 if the current letter is equal to the previous letter, otherwise 0, and then I set the previous letter equal to the current letter, so that way when I go to the for loop again, letter will be compared with the legitimate previous letter, right? Maybe an easier way you could have done this is by looking, like, through each index, right? For like I in range up to the second to last character inclusive, or up to the last character inclusive, be like, look at NXI, look at NXI minus 1, and like, compare those two ever so on. All that matters is that you go through every single letter in the word, and as you do so, keep track of what is the previous letter, and if the current letter and previous letter match, that means that's one letter that Alice might have accidentally typed, right? So there's going to be the string where she didn't type that one, or the string where she did type that one, right? So we add 1 to our result, and we keep doing this for every single letter, and at the end we return the result, and there we go, bada bing, bada boom, we have a nice and efficient working solution, and yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment, but otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye-bye.